Weight and balance problem. Refer to figure 67. Determine the condition of the airplane. They give us the front seat weight, rear seat, baggage, and fuel quantity. What they don't give you in the question, but what you can find in the figure, is the empty weight of the airplane, which is found right here. I'm going to create a table to organize the information. We have the airplane when it's empty. It weighs 2,110 pounds. Weight, arm, moment. Moment is 1,652. Note down in the bottom right, they say all moments are equal to weight times arm in hundreds, and that's key. And so the moment's actually in hundreds. There's even a little slash divide 100 symbol right there. So I don't want to deal with moment in hundreds, so I'm going to put a couple zeros here and change this to 165,200. All right, we're going to have front seat, rear seat. Looking at passengers in the rear seat, they mention its aft position. We'll have baggage and fuel quantity of 70 gallons. For the front seat, we have 375 pounds. Rear seat, aft position 245. Baggage 65. Fuel is 70 gallons. If you take gallons of fuel and multiply it by 6 pounds per gallon, that'll give you the weight. And so 70 multiplied by 6, we get 420 pounds. And then we'll get a total at the end. So this will be our table. For front seat, 375, I'm looking at occupants over here in the table. Front seat, arm of 85. So, put 85 here. If you take a weight, multiply by the arm, that gives you a moment. So, 375 multiplied by 85 gives you 31,875. Rear seat, we have 245 pounds. I'm looking at rear seat. They mentioned aft position and an arm of 136. Weight times arm equals moment. You get 33,320 inch-pounds. Then we're looking baggage. 65 pounds in the baggage compartment. Arm of 150. Weight times arm. 65 times 150 gives you 9,750. Fuel, 420 pounds. I can see fuel right here. And there's the 70 gallons, 420. But I want the arm of 75. Weight times the arm of 75 inches gives you the moment. We get 31,500. Next, we will total the weight and the moment. Total weight is 3,215. And total moment, 271,645. Now, to calculate the center of gravity position, here's the equation. Center of gravity equals the total moment divided by total weight. Total moment divided by total weight, and that gives you about 84.5 inches aft of the datum. That is our center of gravity. So then we'll look at the table right here, and I'm looking for, here's 84, there's 86, that means 85 is right there. We're looking for 84.5 right there. So I'm going to draw a line here. Here's 84.5. It's not that straight. But that's 84.5 inches. And we have a weight of 3215. So here's 32 right here. 3215. Here's weight in pounds. Going across. Looks like it intersects right there. And that falls within the center of gravity envelope outlined in that bold black line. So we are within weight and balance limits. The max weight for this aircraft appears to be right here at about 3,440. So we're below the max weight. If we calculate how much we are below, we can take our max weight of 3,400 and subtract our current weight of 3,215. And you'll determine that we are, looks like we're 185 pounds under the allowable gross weight, and the CG is within limits. So answer alpha is correct.